Right, empirical formula. An empirical formula is the lowest whole number ratio of elements in the compound. So it's like the subscripts are in the most reduced form. Now, because of that, it may not be an actual compound. Ionic formulas are always written as empirical formulas. Remember, our ionic compounds, we always have the lowest whole number ratio, but molecular, not always. So, what are we going to do with this? Well, we are typically given percent data. And now, I have a little rhyme that I found somewhere, I can't take credit for it, for what our steps are with what we do to find an empirical formula. Percent to mass, mass to mole, divide by small, multiply till whole. So those are our 4 steps that we're going to do. Each step is easy. So step 1, percent to mass. All right, I have 25.9% nitrogen, and I have 74.1% oxygen. So percent to mass. Cross out that percent and write a G in its place. Step 1 is done. Now the reason you can do that is because we're getting down to a ratio by mass, well, ratio by moles, excuse me. So by changing the percent to grams, it's like you're saying, I've got 100 grams of the stuff. Second step, mass to mole. Well, I have grams, so grams goes on the bottom. I want moles, so moles goes on the top. When moles and grams are together, moles always gets 1, grams gets the mass from the periodic table. So, nothing that we haven't already done. Another application of it. So, 25.9 divided by 14.01. We get 1.849. Keep, about 4 digits here. We're not rounding to significant figures because eventually we're getting whole number ratios. All right, step 2 is down. Divide by small. So we just take both of these numbers and divide them by whichever one is smaller. So at this step, one of your things is always going to come out to be equal to 1. That one came out to be 2.5. You can't round to 0.5. So that's why we do the last step, multiply till whole. So if we multiply both of these by 2, we now have a 2 and a 5. And those are our subscripts. And we have N2O5. So let's do another one. All right. Percent to mass. Put a G in place of that percent sign. Done. All right. Mass to mole. So I need periodic table. Grams of sodium on the bottom. Moles of sodium on the top. Look up sodium, 22.99. Really didn't give myself enough room here, now did I? One mole of chromium on the top, 52.00 grams of chromium on the bottom, 1 mole of oxygen on the top, and 16 grams of oxygen on the bottom. That is really crunched together. All right, so 17.6 divided by 22.99 gives us 0.7656. 39.7 divided by 52 gives me 0.7. Look at that. Those are pretty much the exact same number. 42.7 divided by 16, we get 2.669. Next up, divide by small. So, and that's basically 1. And that's 1. And that is not 1. 3.49. 3.5. So we've got a stupid 0.5 again. So when we get a stupid 0.5, guess it's not really stupid, it is what it is, but whatever, 0.5 means we have to multiply by 2. So we get 2, 2, and 7, and we get Na2Cr2O7, which is sodium dichromate. So let's do one more. There's 2 more here. We're only going to do 1 more because I'm getting tired of this. All right. 79.8% to mass means I make that grams. All right. Mass to moles, we're going to need the periodic table. Molar mass of carbon is this. And I've got 6.644. Okay, hydrogen is 1.01 grams. And 1 mole of hydrogen. So 20.2 divided by 1.02 gives me 20. Divide by small. Comes out to be 3.01. Yes, that is close enough that you round to a whole number. So our formula is CH3, and we didn't have to do that multiply till whole because it already was whole.